everybody, in this video we're going to recap all of our transformations and the rules that went along with them. So we're going to go through translations, reflections, and rotations. We'll start with translations first. So on a translation, remember that is just sliding our x and y coordinates either up, down, or left and right. So let's start with that up-down movement. Remember, if we were going up, we would see our y value change by adding some number, and let's say a representing any type of number that you can add to my y value. If we were going down, we would see my y value change by subtracting some number, a. So let's start off with a point. I'm going to go ahead and choose 2, 1. So this point is called 2, 1. If I wanted to translate it up, let's say I wanted to translate up 2 points. So I know I'll be going 1, 2 here, and that point is now called 2, 3. Noticing how we added 2 to my y value in order to get here. Just like how we said adding some number to my y value to get a translation up of 2. Now I want to go down and subtract, let's say 3. So I'm going to go and translate down 1, 2, 3. We are now at this point that's called 2, -2. And I get that by subtracting 3, as I said I wanted to go down 3. So that's for our up and down translations. Let's talk a little bit about our left and right translations. Our left and right translations are going to affect my x coordinates. So if I have an x plus some number, I know that I'm going to actually be translating to the right. And if I did x minus some number, I'll be translating to the left. So let's go back to my original point of 2, 1. If I wanted to move 3 to the right, that means I'm going 1, 2, 3 here. And this point is now called 5, 1. What happened was I took my x coordinate and I added 3 to get here. Now let's experiment with moving to the right. Again, starting at 2, 1, I wanted to move, let's say now, 4 units to the left. So 1, 2, 3, 4. This point is called -2, 1. And we did that by taking my 2 and my x coordinate and subtracting 4, just like how we wanted to move left 4. So make sure you take notes on this, that you know where you are moving if we were to add or subtract from our x or y values. Now let's talk about our reflections. So for my reflections, when we did an x-axis reflection, remember that we said we keep our x values the same, but we're changing my sign for my y values. So this negative symbol represents that if my y value was originally positive, it becomes negative, and if my y value was originally negative, this negative will cancel it and become a positive. So that's what it means by changing that sign. Versus if we did a y-axis reflection, we're going to see that the x values change sign, while my y values stay the same. So let's take a look using the point again, 2, comma, y. Okay? So if I'm doing an x-axis reflection, I know that my x's have to stay the same as 2, but this is going to change to a negative because it was originally positive. So I should have the point 2, negative 1, and that's how we know we're doing it with our coordinates. But also noticing that I am reflecting over my x-axis, and it is the same distance away from my x-axis as the original. That's how you know you did that reflection correctly. Okay. Now let's look at our y-axis reflection. I'm reflecting over my y-axis. I know that I have to change the sign of my x value. So instead of positive 2, it's now a negative 2. And my y value stays the same at positive 1. Notice how that point stays in line with my original and keeps the same distance away from my y-axis as my original point as well. So those are our two rules for x and y-axis reflections. This is how you would see it visually on your plane with the coordinates there as well. So our last type of rigid motion that we have here is our rotations. So let's start off with that same point again. I'm going to use 2, 1 for rotations. 2, 1 here is my original. Now, in our Nearpod lesson, we did talk about drawing hooks in order to help us visualize better how to rotate. So I'm going to go ahead and do that and choose a different color here to visualize that hook. Okay, so what they did was draw the horizontal line and then the vertical, just as if you would be when you're counting out how to do that coordinate or plot that coordinate. Now let's start off with the clockwise motion. If I'm going clockwise, that means I'm going down this way. This is clockwise. And I want to go 90 degrees. So in order to bring this up 90 degrees, it will have to match up with this right here, my y-axis. So my hook is now going to look like this, going along my y-axis, and it's still going 2 that way, and then it's going to go across here 1. Okay, so clockwise rotation here happened, and my new point is 1, negative 2. So let's take a look at these coordinates and compare them. I'm noticing that my x's and y's switched places, and one of them is now negative. So the rule here, the general rule, is if this is x comma y, what happened was my y value became my x, and then my x value became my y, and became negative, or changed sign, as you should say. Now, please take notice that this rule is only for rotating around the origin, okay? So this was a 90 degrees clockwise. Let's see what it looks like for 90 degrees counterclockwise. Counterclockwise means we're going to be going this way. I'm going to use a different color to show this counterclockwise motion. I'm going to go ahead and use green. So 90 degrees again, I will have this here in order to show that I am moving 90 degrees. My long horizontal line is now going to be facing upwards on my y-axis, and then it's going past this way. So here's my new point, and this new point is at -1, comma 2. Okay. So again, we're seeing a switch. So at that right, we're seeing that 1 and 2 switch places, but now this x value is the one that is negative. So my rule for a 90 degrees counterclockwise rotation is going to be taking my x comma y and switching them for y comma x, and that this y became negative, or switch sides. So now we did those counterclockwise and clockwise 90 degrees. If we went and did a 180-degree rotation, then we are going to see this part here going to be moving 180 degrees, and then down here to this point right here. And this point is now at -2, comma 1. Okay. So noticing that my 2 and my 1 stayed in the same place, but, oh sorry, this is also -1. But now both of my values have changed to the opposite side. So when we write this, we know that the rule should be keeping my x and y in the same place. However, we are changing the signs of both of them. And that is all of our rules for our rotations. Make sure you capture these in your notes for the different rules. If you have any other questions, you can always contact me.